right, Matrix, let's see if long division worked for you or the smiley face, the inspection method. What did I do? I tested 2. So we got there, we plugged 2 in. Remember, factors of 12, we tested 2, and it actually worked. And we brought it across the equals, and we know that that's our factor. Then what I wrote, I put it into the brackets. I said the x cubed over the x was x squared. It went into there. Then 12 over negative 2 was negative 6, and I put it into there. Okay, check it. X times x squared is x cubed. Negative 2 times negative 6 is positive 12. And we've got our missing term. Okay, now what did we then do? Okay, we then said, okay, fine. Let's connect the terms. How did we do that? Very simply put, we connected those and those. Minus 2x squared and mx squared. And remember, it was minus 1. Where did that come from? From the original that we had. If you go back and check that, remember, it's minus x squared that we're dealing with there in terms of our equation. It's not the original, but it was that number that we needed. Okay, now you divide by x squareds, and you've got m minus 2 is minus 1, so m is 1 if you take that across. Okay, and off we go. So we can plug it back. So let's just go back there. You can put that into there, and very simply, there you go. If I just do that quickly, you would have had x minus 2, and you go x squared plus 1x minus 6 is equal to 0. You could have done it with long division as well, and you would have come out with the same answer, okay, that kind of thing. And then the rest is really, really beautiful, is we then simply say, okay, there it is. We've got m is 1, we replace it, we factorize, okay, x plus 3x minus 2, and what do we then do? We get our x-intercepts there, 2, 2, and minus 3. So those are your x-intercepts for that. And remember, the smiley face or long division comes to play in this thing. Okay, very nice. And you can get marks for this, so master that. Okay, what is next on this show here? What are we going to do now? Okay, so we write our coordinates down, and we get the coordinates of the turning point of the graph. Well, what do we know? Now remember, people, go back to the original. Don't stick with the changed version in the x-intercept form. You start with the original. Now watch this. So we use the rules of differentiation. F prime x minus 3x squared plus 2x to the 1 minus 8 minus 0. We differentiate that thing, and it comes to this. What do we know that happens at a turning point? The derivative is 0. Okay, now we've got a little quadratic equation, and I think I'm going to bring everything to the left to make it a little bit easier. You can, of course, use the quadratic formula if you so wish, if you don't like factorizing. But what I'm going to suggest is that we just factorize normally using grade 10. But of course, minus b plus minus the square root over 2a, that formula is wonderful. You can use that as well. Okay, now we've got all this. Let's look at the slide. Let's try and factorize this. Okay, different signs. Let's see if it works. Okay, remember, differentiate. Minus 3x squared plus 2x plus 8 minus 0. And you put it equal to 0, and let's take it further. Okay, now if we factorize, I'm going to do it directly. 3x squared minus 8, negative 6 plus 4 gives it to you there. And your little x values, minus 4 over 3, or x is equal to 2. Remember, you could have got that from the quadratic formula as well. Okay, now those are the x values of the turning points. We need the corresponding y values. So what do we then do? We then plug into the original, the 2. I'll do the 2 first. It's quite easy. So f2, that comes to 0. That's rather nice. If you plug 2 into the original, you get that. And now we've just got a bit of a mission with this fraction to work out. So f2 minus x cubed plus 2x squared plus 8 times 2 minus 12. And there we go. And we get 2. So our one turning point is a 2 naught. Okay, so please, that was easy. But now the fraction, use your calculator to work out the fraction. Let's have a look at this next one. Okay, of minus 4/3. What are we going to do here? Ouch. Okay, that's a bit mean. Okay, let's see. So we're going to plug it into the original negative, minus 4 over 3 cubed. This is harsh. Okay, let's maybe tidy it up. Okay, we can see, okay, the negative cubed will be a negative times a negative is a positive. 4 cubed, 64 over 27. That gives you 16 over 9. That's great. Minus 32 over 3 minus 12. Now I'm going to simply use a calculator, and I'm going to work that out as that. Okay, and then we've got, I'm just going to change those into nice values there. Okay, good. All right, now, once we've got that, we've got our stationary points. Now, the next thing they're going to ask you is to sketch the graph. Okay, so let's see, what do we know? Okay, to sketch the graph, there's the y-intercept. If x is 0, we've got our little y-intercept as minus 12. Remember, it's the number on the end there. Okay, now let's sketch the graph. Okay, what do we know there? We've got 2, 0, and minus 2. There's your x-intercepts, your turning points, and we've got that. And if we draw that, let's just quickly see. Brilliantly put there. Okay, there's 2, 0 there, minus 3, 0 there, and it's going to come down, cuts the y-axis at minus 12. It turns somewhere there, minus 1 1/3 there, and it goes at 2, 0. So the graph would really do this, comes up there, and turns and does this. And you might want to work out the point of inflection. It actually is at 1/3. If you add up those guys, 2 plus that, you'll get 1/3. That's where the point of inflection is. And there it is, minus 3, 2, and that's minus 12. And there's this point there, and you've got it. So put the arrows on, y and x, and you've got your graph. You might want to continue with that. So Matrix, that was great. I moved fairly quickly through this, but you can go onto YouTube. You can catch Matrix. If you go to the website, you can follow this lesson again and just catch up with what we did. We moved fairly quickly. See you around on Matrix Uploaded. It was great being with you, and we will be back for some more action in mathematics soon. God bless you. See you soon, guys.